Welcome to RuggedMade. Today, we're taking a look at hydraulic cylinders. We offer a range of hydraulic cylinders suitable for many applications. Our cylinders are used on all kinds of machines, from replacing a cylinder on a loader or a dump trailer to custom projects like DIY log splitters and even forge presses. The challenge many of our customers face when shopping for a new cylinder is figuring out which one to get. So our goal with this video is to assist you in determining the right cylinder based on dimensions and a few other specifications. We're going to split this topic into two videos. In this, the first video, we provide an overview of the main parts of a cylinder and we talk about some of the common variations that you should be familiar with in order to find the right cylinder for your project. And then in the second video, which is linked here and in the description below, we'll dive into taking measurements. Now, not everyone is an expert on hydraulic cylinders, or wants to be, and maybe you just want to slap a new cylinder on your machine and get back to work. The good news is you don't need to be a fluid power engineer just to find a suitable replacement cylinder. So how do you get the right cylinder? Well, it mainly comes down to dimensions. If you're replacing a cylinder and you can get the dimensions from an owner's manual or from a dealer, that will save you a lot of time. However, in most cases, the dealer is just going to ask for the model and serial number of your machine and then tell you the part number for the exact OEM replacement cylinder. They're not going to be able to help with detailed dimensions and specifications. Now, this video will not cover the engineering formulas to determine things like cylinder force and flow rates. If you're working on a custom project, you'll need to figure those out first. We're not looking at pumps either because there's so many different kinds of pumps out there. They have a wide range of features from single stage to two stage, designed to be powered by a gas engine versus an electric motor, two direction or single direction, things like that. And more importantly, flow rates could be different and the pressure that the pump can handle. Fortunately, many of the cylinders in common use are rated for a working pressure of 3,000 psi, and that's what most of our cylinders are rated for. When it is time to take measurements, you will need a few tools. A tape measure is sufficient for some of the large dimensions, such as the stroke. To get accurate dimensions of some of the other parts of a cylinder, use a caliper. These are only $10 or $20 nowadays at your local hardware store, so there's really no reason not to have one. And here's a tip to make life easier. All these calipers will show millimeters and inches in decimals. Make sure to get one that also shows inches in fractions. And by the way, this is a caliper and this is a micrometer. You don't need a micrometer for figuring out what cylinder you need. Accurate dimensions are always a good idea, but we're not machining this thing on a lathe. You may also need some specialized wrenches to disassemble the cylinder and get the gland off in order to measure the bore. And here are a couple of examples of some of the tools. Sometimes they're custom made, and sometimes an off-the-shelf tool will work on a lot of different cylinders. Hydraulic cylinders are a type of linear actuator. They're used to create a mechanical force in a straight line through pushing, pulling, or both. Most of the parts of a cylinder are going to be the same, whether you're talking about a welded cylinder or a tie rod cylinder. All the cylinders are going to have a removable gland at the rod end. We'll look at this more closely later, but this basically allows the cylinder to be assembled when it's new and allows you to disassemble it if you need to overhaul it. The main difference is that at the base of the cylinder, the welded cylinder is permanently welded. You can see this bead here, and that welds the base to the barrel, whereas on a tie rod cylinder, this end is actually removable. On a tie rod cylinder, the gland and the end cap are held together against the barrel in tension using these 4 threaded tie bolts or rods. These long bolts run the length of the cylinder, all along the cylinder tube. It's basically a big sandwich. We'll disassemble one later. Additional seals are going to be necessary with the tie rod cylinder to make sure we're sealing the base to the barrel as well as the gland to the barrel. So now let's take a closer look at the smaller parts of a cylinder. Let's start with the barrel. Just like it sounds, the barrel is just a tube. It's the part of the cylinder inside which the piston and rod travel. So here we've got this cool cutaway, and you can see how that's the piston, and that's just going to go up and back along the inside of the barrel. The key dimension here when determining fit is the bore. Bore refers to this inner diameter, or ID, of the barrel. The surface area of this piston, which is pi r squared, that is acted on by the hydraulic fluid, is determined by this bore diameter. And this dimension determines how much force the cylinder can generate. When someone says they have a 4-inch cylinder, they're usually referring to this bore ID, not the outside diameter of the barrel. It'd be confusing to refer to the outer diameter, as that's not going to take into account the thickness of the cylinder walls. So now let's take a look at the rod. So here we've got a cylinder rod. The rod is the part that extends and retracts, and it's secured to the piston and is moved in either direction by the flow of hydraulic fluid acting on either side of the piston. The rods are chrome-plated to reduce friction and minimize pitting, scoring, rust, and problems like that. The key dimension for a rod is its outer diameter. So for this example, we've got an OD of 3.5 inches. Here's one that is 2¼ inches, so that's the rod OD, pretty easy to measure with calipers. The OD of a rod is typically based on what engineers determine is necessary for strength. However, when a fast cycle time is desired, a larger rod can be used. By using a larger rod, if you look at this cutaway, less fluid is going to be needed to fill the space in the cylinder on the rod side of the piston. That's over here, because the rod itself displaces part of the volume. This means less flow from the pump is going to be required to retract the rod. Now, we like to spec large diameter rods on our log splitters because customers often desire a faster cycle time. Let's take a closer look at these pistons. The piston is not unlike the piston in a combustion engine, which is why it shares the same name. So fluid acts on at least one side, such as in a single acting cylinder, which we'll talk about in a little bit, and it pushes on the piston. The piston is usually secured to the end of the rod with a big nut in this case, or in some cases the piston might have internal threads and it is itself a nut and threads right onto the end of the rod. But when it comes to fitting a cylinder, you typically don't need to worry too much about the specific design elements of that piston and how it connects to the rod. We mainly are interested in these other dimensions we're talking about, like the rod OD and the bore and things like that. As this piston travels along the length of the barrel, metal on metal contact has to be prevented. We're talking about the outer edge of this piston contacting the inner wall of the barrel. So this is accomplished by use of these parts here, which are called guide rings. They're also known as wear rings or support rings. We're talking about the same thing. So those are wear rings, that's a wear ring, and here we've got a wear ring. So the wear ring is made out of a material that has to be tough enough to support the piston, and yet soft enough not to damage the inner surface of the barrel. And so it's made out of usually some sort of fiberglass, fibrous material. They're pretty tough. They have a pretty long service life, but they can wear out. If we look inside a gland, we can see that there's also internal wear rings, and instead of supporting the piston, they're going to support the rod at this end. And so here we have a couple of examples of some smaller wear rings that would go in there, and that supports the rod as it goes in and out of the gland. Fluid will follow the path of least resistance. If the gap between the wall of the piston and the inner surface of the barrel isn't sealed, well, fluid's going to escape across that, and that's what's known as blow-by. If there's no resistance to the flow of fluid, well, pressure is not going to build. So the guide ring is usually too hard to act as an effective seal. So a piston seal made out of a material like nitrile rubber, polyurethane, or Teflon is used. And we're talking about that seal there, this seal here, and that is going to prevent the fluid from escaping. And just like with the support rings, we've got these outie support rings that keep the piston away from the wall of the cylinder. And then we also have sort of the innie support rings, or rather seals, that are going to seal the gland where the rod is going to travel. And that's the job of this. In this case, it's a cup seal, and it's the main seal doing the job of holding the pressure back so that it doesn't escape through the gland and leak out all over your machine. And by the way, this blow-by effect of a worn-out seal is one of the most common reasons that a cylinder might only need to be overhauled and not completely replaced. So this is the bottom of the cylinder barrel. It also goes by the name of base or cap. It seals the extend end of the cylinder barrel so that the pressure can build and push the rod out. Cylinders are often mounted at this end. Here we've got a tube mount example. There's a clevis mount example. And the base can be cast, forged, or machined steel. And the bases are either welded to the bottom of the barrel, or in this case we have our tie rod cylinder where it's secured by those rods and held with compression. So this is the gland, and it's also called a head or a bearing. So basically we're talking about the end with the hole for the rod to go in and out. The gland seals the open end of the cylinder so the pressure can build and be maintained while the piston and rod are extending and retracting. The gland also plays an important role in maintaining the alignment of the rod. So when you're disassembling a cylinder, you don't want to let this rod flop too much. RuggedMade welded cylinders feature threaded glands. This design requires more precision machining, but it's also able to withstand high pressures. tie rod cylinder glands are going to be secured to the cylinder barrel by the pressure created from the tension of these 4 tie rods or bolts. And the gland can also be retained inside the barrel using a snap ring, although these types of cylinders typically are rated for lower pressures. This is the dust or wiper seal, and it's usually the one that you can see from outside. Many people mistake this for the seal that's actually doing the rod seal's job in keeping that high pressure fluid inside the cylinder. But this dust or wiper seal, its actual function is just to prevent dust and debris from getting inside the cylinder, hence the name. And finally, the mating surface, where the gland interfaces with the inside of the cylinder in this threaded area, that has to be sealed. And this applies to both welded and tie rod cylinder glands. And it's usually accomplished with an O-ring because that's a static place. The rod isn't rubbing along that. It just gets cinched down and seals. A cylinder needs to be mounted with at least 2 points of contact, one somewhere along the barrel and one at the end of the rod. There are many different types of mounts depending on the application, but let's take a look at a few common types. So here we've got a ball swivel type of mount on both ends of the cylinder. Here we've got a snowplow cylinder, which has a pin eye on both ends. So that's just a solid end of the rod with a hole drilled through it for a pin. Here's one of the most common types, which is clevis. So we've got a fixed clevis at this end. It's a cast piece or it could be welded, but that's a fixed clevis. The clevis at this end, it could be welded to the end of the rod. In this case, it's a thread-on. And the other, probably most common type would be cross tube. The base of most cylinders will have a mounting point, but there are a couple types that don't. If you look at the base of this cylinder, there's no mounting point there because it's what we call a trunnion mount, kind of like named after a cannon. So you got 2 ears here welded to the barrel, and that's how the barrel would be anchored. Another type of cylinder that doesn't have mounts at the end, it would be a flange mount. There are many variations on these mounting types. There are even hybrids. You might have clevis at one end and a cross tube at the other. That's kind of a unique cylinder, but you know what kind of mounts you have. And if you're not sure what they're called, you could do some Googling and you'll figure it out. The key thing we need to do is get the dimensions of these mounts once we've identified the type. So we're going to be looking at in the case of a cross tube, we need the length of the tube, we need that pin diameter. There could be, in the case of a clevis, you need to know that gap and basic dimensions like that. Most cylinders mount using 2 pins. Some use bolts, like the trunnion that we looked at earlier. Flange mounts usually mount with bolts, but most are going to mount with a couple of pins. So we've got a few examples of pins. You basically just need to measure the length and the diameter of a pin. So 1-inch diameter, and this one is a 4-inch pin. We've got a 4.5-inch pin. And note that some cylinders are going to mount with 2 different length pins. In the case of this clevis, and it's very clear in the case of this cross tube that there's a shorter end and a longer end. If the cylinder that you found is perfect in every way, but the size pin that it's meant to take is larger than what your machine calls for, it is possible to shim a pin diameter up. Pins are secured with things like spring clips. They're often secured with a cotter pin, in the case of these 2 pins. In this case, it's 2 cotter pins, one at each side. In this case, there's a machine flange and a cotter pin at one side. And there's some have a rebated slot for a circlip. But those details aren't all that important. Just check that the old ones on your machine, if you're replacing a cylinder, are still in good shape, and if they're worn out, replace them. And keep in mind, some machines have a sacrificial bushing, like on a Bobcat boom pivot mount. There's a bushing there that will wear out. So when you're replacing a cylinder on something like that, that'd be a good time to check the condition of that bushing, maybe replace that. You definitely don't want this pin starting to contact the actual metal of the frame and wearing that out. Some connections are designed to be greased. If you're replacing a cylinder with a grease fitting, make sure the new one has one as well. You can't just get a cylinder that's not designed to have a grease fitting and drill and tap a hole, because there won't be a rebated slot inside there that would allow the grease to get all the way around the pin. Measuring the stroke of a cylinder is the thing that trips people up the most. The stroke is the difference of the distances between the piston's fully retracted and fully extended positions. In other words, when the rod is fully retracted and you extend it all the way, the distance that it travels is your stroke. Confusion tends to creep in when people casually use terms like length. That can mean a lot of different things, so we will avoid using this word unless we specify exactly which length we're referring to. The majority of cylinders mount to equipment with a pin at the base and a pin at the rod. Therefore, the simplest way to measure the stroke is the distance between the two mounting points when fully retracted and when fully extended, and this is known as the pin-to-pin distance between the two mounting holes. And more specifically, we're interested in the pin center to pin center length. We show this dimension in the schematic for each cylinder at RuggedMade.com. When a clevis mount is threaded onto the end of the rod, as with this example, it needs to be threaded on almost completely for a strong connection. However, this design does allow for a small amount of fine-tuning of the mounting length. This can be helpful when you need a little more or a little bit less length to make the cylinder fit your machine. Just keep in mind this doesn't change the stroke, it just slightly changes the mounting dimensions. The port is the hole in the wall of the cylinder that allows hydraulic fluid to flow into and out of the cylinder barrel. In this case, it's a piece of tubing that's welded to the outside of the cylinder barrel. Sometimes it's created by drilling and tapping a hole in the body of the base or the gland, like on this tie rod cylinder, which has cast ends. One thing we do see from time to time on some old cylinders, and again, you're maybe thinking about a replacement cylinder because you've got one of these old cylinders. Well, if some of these old cylinders have seen a hard life, sometimes we see a fitting that's actually been welded to the port in order to maybe fix a leak from a crack or some stripped threads. So just keep that in mind if you're trying to figure out what your port dimensions are. Now, two of the most common thread standards used for high-pressure hydraulic connections are NPT, or National Pipe Tapered, or ORB, or O-ring boss. Now, NPT is essentially the same thread that has been in use in plumbing for over 100 years. It's a tapered thread, which means that the walls, as you line it up, they're going to converge. It creates a seal when the threads of the tapered male end get tightened into the female end and the threads actually deform, and that interface creates the seal. Now, Teflon tape or a sealing compound is recommended to prevent leakage. There's also NPTF, or National Pipe Tapered Fuel, and this is a dry seal thread standard, and it's supposed to obtain a seal without any sealants. However, for hydraulic applications, use of some tape or thread sealant is still recommended. Both NPT and NPTF are suitable for hydraulic connections, and for all practical purposes, most people treat them as interchangeable. O-ring boss is a parallel thread, so these two threads remain parallel, unlike the taper thread on the NPT. They don't rely on the threads interfacing to create the seal. The seal is created when this O-ring is compressed between the two mating surfaces as this fitting is threaded into a cylinder or a valve, and it's mechanically pulled together. So these two thread types are easy to distinguish. One's parallel, one's tapered, pretty straightforward. There are some other standards out there, such as BPT for British pipe thread or British pipe tapered. O-ring face seals, a little bit different from O-ring boss, as well as some national standards for other countries like Germany and Japan. So this variety can make things kind of interesting, but if you do this kind of work routinely, you're probably going to need to invest in something like a gauge and a guide it's a thread gauge, pitch gauge, which will help you identify the thread types. Fortunately, NPT and O-ring boss are the most common in the US, so identifying the thread standard is going to be actually the easy part. Measuring the size is where it gets tricky, because the physical measured dimensions off of your tape measure or caliper, they don't tend to have any relation to the nominal dimensions that the parts are named for when you're trying to say, I need a cylinder with this size port, or I need fittings of a certain size. So we'll look at a few examples later. If you're replacing a cylinder, you want your new cylinder to have the same size of ports and ideally to have the same thread type in order to utilize the original fittings and hoses. However, you may not be able to find a cylinder that matches perfectly. For example, your original cylinder has O-ring boss ports, and the only replacement cylinder that you can find is an exact match in every way, except that it's only available with NPT ports. This is not the end of the world. It's usually pretty easy and inexpensive to use adapter fittings to connect your original hoses to the different type of port threads on your new cylinder. The connection to the hoses, which is probably going to be 37-degree JIC compression, those would be the same. Determine whether you need a single-acting or double-acting cylinder. Single-acting cylinders typically only need one port, and it's usually located at the base end of the barrel. When fluid gets pumped into the cylinder, the rod extends. Hydraulic pressure is not used to retract the rod. Single-acting cylinders usually rely on an internal return spring, the weight of the load under gravity, or the counteracting force of another cylinder to retract the rod. A couple common applications would be a dump trailer, where the weight of the trailer is going to lower it, or a snowplow cylinder like this, where two of them are operating in opposition for the angle of the plow. Double-acting cylinders have at least one port at each end of the barrel. Pumping fluid into the base end will extend the rod, and pumping fluid into the gland end will retract the rod. Log splitters and tractor boom and bucket cylinders are typical examples of double-acting cylinders. Some double-acting cylinders may have additional ports. For example, this tie rod cylinder has the two ports we looked at when we were looking at fittings, but it has an additional port here at the base. Now that could just be for access when this is installed. You might not be able to get a fitting into this because of the frame of the machine it's on. But some log splitters, for example, have a second port at the base end, and that's to facilitate faster evacuation of the fluid directly back to the tank through what is called a dump valve. In this application, there would also need to be a small port at the gland end, and this would be for a hydraulic line. It connects to the dump valve's pilot-operated bypass cartridge. Such cylinders tend to be unique proprietary designs. However, the same function can be accomplished by adding T-connections outside of the cylinder. And most cylinders just have two ports. Before you run out and buy a new cylinder to replace one that has failed, try to identify the cause of the failure. People usually replace a cylinder when they know exactly what failed. It may have a crack, or a bent rod, or the chrome on the rod is damaged. But if you're shopping for a replacement cylinder because you feel like your machine doesn't have enough power, just make sure it's not something like a pump, or a valve that has failed, or something like a very inexpensive filter element that's clogged. And remember that sometimes a cylinder just needs to be overhauled with a new set of seals to get it back in action. That concludes our overview of the parts of a hydraulic cylinder. Go ahead and watch part 2, where we measure the key dimensions of a cylinder so you can find the right cylinder for your project. We're continually expanding our lineup of cylinders, and this includes more sizes and more types of cylinders for specific applications. If you don't see what you're looking for, contact our customer service department. Thanks for watching.